The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to eventually go on and look at section 5.6 and 5.7. But before we do that, someone had a question from yesterday's assignment. So we're going to take a look at that. Can everybody see the WebAssign screen there? Somebody just tell me yes, if you can.
Yes.
Thank you. Thank you. I know. All right. So problem 25. So this is section 5.4, number 25. The polynomial 4x cubed. So we got 4x cubed minus 42x squared plus 110x gives the volume in cubic inches of the resulting box when a square with sides x inches long is cut from each corner of a 10 by 11 piece of cardboard. Find the volume of a box if 2-inch squares are cut out. All right. It looks like a fairly complicated problem, but basically it boils down to this. They've given us this polynomial that gives the volume when a square with side x inches long is cut. They've told us that the side is 2. So basically what we're going to do is this. We're going to take this polynomial and evaluate it when x equals 2. So we're going to have 4 times 2 cubed minus 42 times 2 squared plus 110 times 2. Let's see here. 2 cubed is 8. 2 squared is 4. And so we've got what? 4 times 8. Helps if you turn the calculator on first. 4 times 8 is 32 minus 168 plus 220. And if we have 32 minus 168 plus 220, we get 84, and that would be cubic inches because it's a 3-dimensional box. Any questions about that particular problem? All right. Then,
I have a question.
yes.
Sorry, it takes me a minute to find the mute button.
Okay.
I got a different answer.
Okay.
But
Go ahead.
I thought I got it right on the homework.
I'll bet when you go and look at your homework on your problem, the box won't be 2 inches. It'll be something else.
Oh, so the numbers are different on our homework?
Exactly. The numbers are anything that's in red could be different from one person to another on the homework and the test. Okay.
Oh, okay. Thank you.
There you go. All right. Anybody else? Okay, well, we'll go ahead and get out of that and we'll go back to looking at sharing my whiteboard screen. And we'll take a look at section 5.6, which is multiplying polynomials. Okay. What I want to do, first of all, and I keep making reference to the past, is to go back and look at some ideas at the beginning of this chapter. We kind of started in the middle of this chapter. Math 85, I believe, covers the entire chapter. Math 84 covers part of it. But anyway, I want to compare adding or subtracting like terms versus multiplying. Okay, so let's say we have 2x plus 3x. We're adding like terms. So as we looked at yesterday, this would be 5x. But let's say we have 2x times 3x. This is going to be 6x squared. Where are we getting that? Well, let's take a look. 2x times 3x. Multiplication is commutative. 2 times 3 equals 3 times 2. We can rearrange factors, things that are being multiplied. So we could rearrange this big product as 2 times 3 times x times x. 2 times 3 is 6, and x to the 1 power times x to the 1 power would be x to the 2 power. So we get 6x squared. All right, the general rule says this: when you're multiplying 2 powers with the same base, so let's say we've got a to the m times a to the n power. When you're multiplying 2 powers with the same base, you add the exponents and attach them to the common base. So x cubed times x squared would be x to the 3 plus 2, or x to the 5th power. Y to the 14th power times y cubed would be y to the 17th power. Any questions on that before we go on? Okay, so let's take a look at some problems from section 5.6. This first one says 5m times m, and the directions say multiply. So this would become 5m squared, because m to the 1 power times m to the 1 power would be m to the 2 power. Don't forget that when there's no exponent, there is a 1 exponent implied. All right, we okay with that? Here's another example. Negative 2a cubed times 11a squared. Negative 2 times 11 would be negative 22. A cubed times a squared would be a to the 5th power. So our final answer is negative 22, a to the 5th power. All right. 2.5 h to the 4th power times 2h to the 4th power. 2 times 2.5 is 5. H to the 4th times h to the 4th is h to the 8th. Well, I'm just going to keep doing examples. If you have questions, shout out, stop me, okay? Otherwise, I'll just keep going here. Now, here we have 3y times 7y squared times negative y to the 4th. Multiplying the coefficients, don't forget there's an implied 1 with that negative. So we've got 3 times 7 times negative 1 would be negative 21. Y to the 1 times y to the 2 is y to the 3rd power, times y to the 4th is y to the 7th power. Okay, let's see here. Negative 2/3 x to the 6th power times 9x to the 3rd power. Multiplying the coefficients together, negative 2/3 times 9, the 9 over the 3 reduces to a 3 over a 1. So now we have negative 2 times 3, which is negative 6. X to the 6 plus 3 is 9th power. So negative 6x to the 9th power. All right. Now we're going to continue to multiply, but we're going to be using the distributive property. So if I have 3a times a plus 2, we're going to multiply 3a times a, which is 3a squared, plus 3a times 2, which is 6a. These are not like terms, so that's as far as I can go in terms of combining them. All right. Let's say I've got negative 4b cubed times the quantity 2b squared minus 2b plus 2. Once again, we're going to use the distributive property. Negative 4b cubed times 2b squared is negative 8b to the 5th power. Negative 4b cubed times minus 2b, negative or minus times minus is plus. 4 times 2 is 8. B to the 1, 2, 3, 4th power. And then negative 4b cubed times a plus 2 would be minus 8b cubed. My answer is a trinomial. There's no like terms there. Notice I've got it written in descending powers of b, which is what's known as standard form when you have it written in descending powers. All right, we okay with that? Okay, let's take a look at this problem. 4/9 a squared times 9a cubed plus a squared. So I'm going to distribute here, which is going to give me 4/9 a squared times 9a cubed plus 4/9 a squared times a squared. I'm not going to reduce it as I go because I think it's a little bit easier to follow this way. So I've just distributed. Now I'm going to go back and reduce things. The 9 over the 9 reduces to 1 over 1. And I have 4 times 1, which is 4a to the 5th power, plus, let's see, nothing reduces on the second product, 4/9 a to the 4th. So there's my final answer. All righty. So now we're going to expand this idea of the distributive property. Let's say we've got this. We've got y times the quantity y plus 5, and then plus 3 times the quantity y plus 5. So we're going to take y times y plus 5, and then 3 times y plus 5. So distributing, I get y squared plus 5y plus 3y plus 15. But continuing on, I can simplify by combining like terms and get y squared plus 8y plus 15. Okay, so I took y times y plus 5 and then plus 3 times y plus 5. And I ended up with y squared plus 8y plus 15. Now I'm going to write it a little bit differently. I'm going to say the quantity y plus 3 times the quantity y plus 5. We're actually going to do the same process. We're going to start by taking the first term of the first factor, that is y times y, which is y squared. Then we're going to take y times 5, which is 5y. So now we've taken the y in the first factor, or in the first parentheses, times everything in the second parentheses. So now we'll move to the second term, plus 3y plus 15. Combining like terms, y squared plus 8y plus 15. Any questions on that example? I want to look at it again. Y plus 3 times y plus 5. This is sometimes called FOIL. And FOIL stands for first, outer, inner, and last. I can never remember if outer has one T or two T's. Any English majors here? Oh, just has one T. Oh, well, I knew something didn't look right. I just wasn't sure what. So how are we getting that? Okay, so we're going to take the first times the first. Then we're going to do the outer two. Then we're going to do the inner two. And then the last times the last. Okay, so that's why they call it FOIL, just to kind of remind you what to do. First, outer, inner, last. Again, any questions about that process? Okay, let's look at a bunch more examples. How about this one? A plus 4 times A plus 5. So I've got 4 products. A times A, which is A squared. A times 5, which is 5A. 4 times A, which is 4A. And 4 times 5, which is 20. I want to remind you of something from the past. When I took A times 5, I could have written A5, but we instead write 5A, we put the coefficient in front of the variable. Okay. All right. Then combining like terms, A squared plus 9A plus 20. And there's our final answer. So we're multiplying 2 binomials together, and the product is a trinomial in this case. Okay, let's see here. How about this one? 3x minus 4 times x plus 5. 3x times x is 3x squared. 3x times 5 is 15x. Minus 4 times x is minus 4x. And minus 4 times plus 5 is minus 20. Combining like terms, 3x squared plus 11x minus 20. Okay, let's take a look at one involving decimals. If I need to slow down, if you're not getting everything written down quickly enough, tell me. I'm happy to slow down. I'm not in a hurry. I'm not going anywhere. 2.6x minus 3 times 2x minus 1. All right. 2.6x times 2x. Well, 2.6 times 2 is 5.2x squared, because we have x times x. 2.6x times minus 1 is minus 2.6x. Minus 3 times 2x is minus 6x. And minus 3 times minus 1 is plus 3. Combining like terms, 5.2x squared minus 2.6x minus 6x more would be minus 8.6x plus 3. Okay, let's look at one involving fractions. Just keep saying fractions are our friends. 8t minus 1/2 times 4t minus 2/2. 8t times 4t is 32t squared. 8t times minus 5/2, let's see, that would be minus 8t times 5/2. I'm going to come back and simplify that later. Then I've got minus 1/2 times 4t, and then minus 1/2 times minus 5/2. Okay? So 32t squared The 8 in the numerator and the 2 in the denominator reduced to 4 over 1. So now I've got minus 4 times 5 is 20t. The 4 in the numerator and the 2 in the denominator reduced to 2 over 1. So now I've got minus 1 times 2 minus 2t. And then finally, multiplying fractions together, let's see, negative times negative is positive. We multiply straight across, 5/4. But we can still combine like terms. So we've got 32t squared minus 20t minus 2t is minus 22t plus 5/4. Any questions there? All righty. Take a look at this problem. S cubed minus 6 times s cubed minus 8. So s cubed times s cubed is s to the 6th power. We're adding the exponents, 3 plus 3. S cubed times minus 8 would be minus 8s cubed. Minus 6 times s cubed is minus 6s cubed. And minus 6 times minus 8 would be plus 48. Combining like terms, s to the 6th power, minus 8s cubed minus 6 more s cubed would be minus 14s cubed plus 48. Okay. Let's take a look at another example that has more than one variable. 2t plus 3s times 3t minus s. Okay, so I get 6t squared minus 2st. Notice that within the term minus 2st or negative 2st, I put the variables in alphabetical order. If I always do that, it'll make it easier to identify when terms are alike. So then this becomes plus 9st, and finally minus 3s squared. So my two middle terms are like terms. So I've got 6t squared minus 2st plus 9st is plus 7st minus 3s squared. Okay, again, because if I wrote the first one like that and then the second one like that, you might not see that those are like terms. So you always want to put variables within the term in alphabetical order. Okay. Now, let's see here. We've got x plus 2 times x squared minus 2x plus 3. Well, technically, we can't really FOIL anymore because we don't have a binomial times a binomial. But we can do the same idea by starting at the left and taking the first term times that, and then times that, and then times that, and then taking the second term times that, and then times that, and then times that. So we're going to have 6 products. Okay, so our first one, x times x squared is x cubed. X times minus 2x would be minus 2x squared. And then x times plus 3 would be plus 3x. So there's our first 3 products. Then moving on to the 2 times x squared plus 2x squared. 2 times minus 2x minus 4x, and then 2 times 3 is a plus 6. So there's my 6 products. Then I'm going to come back and combine like terms. These are like terms and those are like terms. So I've got x cubed minus 2x squared plus 2x squared. Those are just going to cancel out. Plus 3x minus 4x would be minus 1x. And remember, I'm not going to put that implied coefficient there. It isn't wrong, but WebAssign doesn't recognize it. And then finally, plus 6. Okay, let's see here. How are we doing for time? We're doing okay. All right. How about this one? We're going to take a trinomial times a trinomial. So we're going to have what? 3, 6, 9 different products. All right, here we go. W squared times W squared is W to the 4th power. W squared times minus W is minus W cubed. W squared times 3 is plus 3W squared. W times W squared is plus W cubed. W times minus W is minus W squared. And W times 3 is plus 3W. Minus 9 times W squared is minus 9W squared. Minus 9 times minus W is plus 9W. And minus 9 plus or times positive 3 is minus 27. Okay, so let's see. I've got W to the 4th power. Then these two are like terms, but they're going to cancel out. This one and this one and this one are like terms. 3W squared minus 1W squared is 2W squared. Minus 9W squared is minus 7W squared. Okay. And then I've got, what is it? 3W plus 9W, which is 12W. And finally, minus 27. How fun is that? Okay. Any questions on that one? All right. Now, let's see here. I want to make that red. What if we had 2 times 3 times 4? Do you multiply the 2 times the 3 and the 2 times the 4 like when you distribute? No, you multiply 2 together and then keep going. So 2 times 3 is 6. 6 times 4 is 24, right? So we multiply the first 2 factors together, get the result, take that times the next factor. Okay, now let's say we've got 4x times 2x plus 1 times x minus 2. So this is just like having 2 times 3 times 4. We're going to multiply these first 2 together. Okay, so that's going to give us 8x squared plus 4x. But now we're going to take the results times the final factor that's in the parentheses. Okay, so then this is going to become 8x cubed minus 16x squared plus 4x squared minus 8x. We've done all the multiplication, so now we're going to combine like terms. So we're going to get 8x cubed minus 16x squared plus 4x squared is minus 12x squared, and then minus 8x. Any questions about that example? All right, let's take a look at another example. here we have negative 2a squared times negative 3a cubed times 3a minus 2. The first two factors we're not going to be distributing. It's just pure multiplication. Negative 2 times negative 3 is positive 6, and then a to the 5th power. All of that times the 3a minus 2. So now we're going to distribute. 6a to the 5th times 3a is 18a to the 6th power. 6a to the 5th times minus 2 is minus 12a to the 5th power. These are not like terms, so there's our final answer. All right, now we're going to take a binomial times a binomial times a binomial. And again, we're going to do these two at a time. So we're going to do these two first. So that's going to give us x squared minus 2x plus 6x minus 12. But that's x squared plus 4x minus 12, combining like terms. Okay, so foiling together the first two binomials, we get that bottom trinomial. Then we're going to take that times x minus 4. So we get x cubed minus 4x squared plus 4x squared minus 16x minus 12x plus 48. Negative or minus 12 times minus 4, negative 12 times negative 4. Combining like terms, we get x cubed. These are going to cancel. Minus 16x minus 12 more is minus 28x plus 48. And there we have it. Okay, let's see here. We're going to look at some things where the author calls them lookalikes. Okay, so let's take a look here. The first problem, problem A, is x minus 2 plus the quantity x squared plus 2x plus 4. The second problem, problem B, is x minus 2 times the quantity x squared plus 2x plus 4. So the first problem is addition. The second problem is multiplication. Quite often on a test, a common mistake that I see, students have problems like this first one, but they treat it like the second one. So pay close attention to the operations. All right, so this first one, we're adding two polynomials. Since there's nothing in front of the first set of parentheses, x minus 2, plus the second set of parentheses, distributing a plus sign, we just get plus x squared plus 2x plus 4. Combining like terms, we get x squared plus 3x plus 2. So adding those two polynomials, we get x squared plus 3x plus 2. Okay. Now, let's multiply those polynomials together. We're going to get x cubed plus 2x squared plus 4x minus 2x squared minus 4x minus 8. Combining like terms, the 2x squared, the minus 2x squared cancel. The plus 4x and the minus 4x cancel, and we just get x cubed minus 8. So we get a very different answer depending on the operation. So pay close attention to what they're asking you to do. Okay. Let's see here. Let's do another one involving decimals. This says 0.5 u to the 5th power times 0.4 u to the 6th power minus 0.5 u to the 3rd power. So be careful. All right, distributing 0.5 times 0.4. Do you remember when you're multiplying decimals what the rule is? So you multiply just like normal. Let's see, 5 times 4 is 20. So our initial decimal point's right here, but we're going to move it over 1, 2, 1, 2, so 0.2. We move it over the total number of places that there are digits to the right of the decimal point, okay? So this becomes 0.2 u to the 11th power. And then we're going to take what? 0.5 times 0.5. Let's put the multiplication symbol there, which is 25, 1, 2, 1, 2, so 0.25. So what? Minus 0.25 u to the 8th power. So there's a lot going on in that problem. Okay. All right. Well, that's it for section 5.6. So I'm going to stop the recording in a minute. We'll take a 5-minute break and come back. Before I do that, are there any questions? Anything you want to look at before we move on? Okay, so we'll stop the recording.